All right, here is the 9-3B classwork number 26, the problem we worked on in class. It's y equals 4x over x cubed minus 4x. Now, something we have to understand about all these graphs is we're trying to find landmarks, and there's 5 categories of them. These landmarks are where we know points are on the graph of the function or, like around the asymptotes, where the behavior of the graph of the function is predictable. That makes our sketch of our graph something we can use and interpret in the context of a real-world problem. Okay, so I'm going to show this graphing landmarks for all these 5 videos, and also factoring is very, very important because you have to factor to find the holes or vertical asymptotes or horizontal asymptotes, and here are some factoring tips. Always look for a greatest common factor, try difference of 2 squares, and then go to the magic x if it's a trinomial. Remember, like factors cancel, or they become common zeros, and we need to use the zero product property, so change the sign to find the actual zeros. So let's go through and factor this completely. The top stays the same, but the bottom has a GCF. There's an x there and there, so we can factor out that GCF, and it becomes x squared minus 4. That becomes a difference of 2 squares, so we have 4x over x times x plus 2 and x minus 2. The common zero is right there. It's at x equals 0. So that means I have a hole. The first thing we look for is a hole, common zeros at x equals 0. Okay? There's parentheses there. Now, any other zero of the denominator becomes a vertical asymptote. So this is category 1. Category 2, the other zeros of the denominator become vertical asymptotes. And they're right there at x equals plus and minus 2. Okay? Horizontal asymptotes, we're going to go back to the original function and do degree analysis, the degree of the polynomial in the numerator and the denominator. This is a 1, so this is first order. This is a 3, so this is degree of 3. The degree of the denominator is greater, and we learned that that means the horizontal asymptote is at y equals 0 for category 3. X-intercepts and y-intercepts are points that are on the graph that intersects the axes, and we can usually figure out what they are. So these help us predict where the graph of the function is. Number 4, x-intercepts are zeros of the numerator. In this case, it's just 0, and x-intercept is x equals 0. But this is misleading because the y-intercepts, if I plug in 0 for x here, it becomes 0 over 0. So you would think that y equals 0 is also an intercept, but this is misleading because of some calculus and what's called L'Hopital's rule. We would have to differentiate this to find the actual undefined point, and I'll show you that on the graph here in a minute. So this part for this problem is misleading. However, now that we have all of our landmarks, we can go ahead and we can graph this. Only put arrows on your axes. Let me make sure you can see this. Okay, so we know there's a hole at x equals 0, so we just keep that in mind. First thing we do is at plus and minus 2, we draw our asymptotes. Vertical asymptotes you cannot cross. Vertical asymptotes you cannot cross. Sometimes in the middle of a graph, you can cross over horizontal asymptotes, but that's only sometimes. Horizontal asymptotes only describe the end behavior on the far right or far left of the graph. That's something to keep in mind. Okay? Y equals 0. That means this axis is also an asymptote. All right? And we have x and y intercepts. We don't really know what those are. So what we've got to do next is do number analysis. We've got to plug in a number, start from this asymptote way over here, like let's plug in 10. Let's plug in 10 here, or yeah, if we plug in 10 here, we get 40 over 10 cubed is like 1,000. 1,000 minus 40 is 960. That's a positive number, but it's a really small number. So that means it's something like this. So that means our branch here goes like that. Let's do the same thing over here at negative 10. This was 10. This is negative 10, and just figure out what it is. So that's negative 40. If I plug in negative 10, I get negative 40 over negative 1,000 minus 40. Well, this is again a positive number, but it's really small here, so this branch looks like that. Now, the last thing to teach you guys is about how the graph behaves usually. This is a rule of thumb. How the graph behaves over an asymptote. This function is going up here as we get closer and closer in x values to this asymptote. This function is going up towards infinity. When you jump over the asymptote, usually it goes down to negative infinity. So this part of the graph are here, and because this one is on positive infinity here, this one goes to negative infinity. And the only other point is going to be at x equals 0. It's undefined. Remember, there's a hole, and I would have to show you a lot more stuff on a graphing calculator as to why that point is there instead of at x and y equals 0. But it has to do with calculus. Suffice to say, make sure you have a hole, and this is a upside down U shape because outside the branches the graph looks like that. Sorry this was such a long video.